In this video, we're going to be talking about being able to find the conjugate and being able to use that conjugate to find a quotient of complex numbers. So basically, we're dividing complex numbers. But there's something called a conjugate that we need to understand how to find first, because we use that conjugate to help us with the process of dividing complex numbers. So when we want to find a conjugate, we look at the problem and we are only changing the sign or operation of the complex number portion. We do not change the sign of the real number. So remember, it's not imaginary unless it has that I, right? Or it's the square root of a negative number. So for this first example, the conjugate would be 4 minus 6i. Notice the 4 stayed positive, but the 6i became negative. In the second example, we have a negative 5, that's real, but then we have a minus 3i, so that becomes a positive 3i. In the third example, we have 8i, which is imaginary, so we make that a negative 8i. And then in the last example, 6 is a real number, so there's actually nothing to change. So we're going to keep it 6, but theoretically there is no conjugate because there is nothing imaginary in that problem. All right, so that brings us to dividing complex numbers. All right, so when you divide a complex number, you want to make sure that it's in the proper form. So these are fractions with complex numbers. This is dividing complex numbers. But basically in math, you have proper forms. So kind of like in English class where you have to start a sentence with a capital letter, you have to end it with punctuation. Same kind of thing here. It's not proper to have an imaginary number in the denominator. All right, so we're going to follow this process, and it says we're going to find the conjugate of the denominator first. So in this case, the conjugate would be negative 6i. Then it says we're going to multiply the numerator and the denominator by whatever that conjugate is. All right, so we're going to multiply the numerator by a negative 6i, and we're going to multiply the denominator by a negative 6i. All right, so we're going to multiply straight across, so we get negative 60i squared over negative 36i squared. All right, and then don't forget that I squareds get replaced with a negative 1, all right, which ultimately just changes the sign of whatever you started with, right? So that would be positive 60 over positive 36, and then 12 goes into 60 5 times, 12 goes into 36 3 times. So my answer would be 5/3. Now, theoretically, this problem, we could have reduced it from here. We could have canceled out the i's, and then 10 over 6 would be 5/3. I only did this process because I wanted you to understand, the process of the conjugate and multiplying by the conjugate. All right, so in the second example, the conjugate is a negative 3i. All right, so this one you can't just cancel things out. You can't cancel out these i's because there's a group in the numerator, 2 plus 5i. All right, so we're going to multiply across. All right, we're going to say 2 times negative 3i, and we're also going to have 5i times negative 3i. So 2 times negative 3i is negative 6i. 5i times negative 3i is negative 15i squared over a negative 9i squared. And then remember, the I squareds get replaced with a negative 1. All right, so in the numerator, that gives me negative 6i, and then a negative times a negative makes that a positive 15 over negative times a negative makes that a positive 9. Now, there's two things wrong with this answer. Number one, it's not in standard form. Number two, it can be simplified. All right, so the first thing I'm going to do is go ahead and reorder it. 15 minus 6i over 9. Remember, you put the real before the imaginary. Now we can reduce that because every single one of these numbers is divisible by 3. All right, so 3 goes into 15 5 times, 3 goes into -6, -2 times. 3 goes into 9, 3 times. All right, so that's a good answer. Another way that you can write that, though, would be 5/3 minus 2/3 I. All right, so either of those would be acceptable. All right, so another example, all right, we would multiply by the conjugate of the denominator, so the conjugate would be 4 plus I. All right, so I'm going to multiply 6 times 4, that's 24. 6 times I, which is 6I. And then I'm going to multiply the -5I times 4. So that is -20I. And then I'm going to multiply the -5I times the positive I. So that is -5I squared. Now I'm going to do the same thing in the denominator. All right, so 4 times 4 is 16. 4 times I is positive 4I. Now the -I times 4 is -4I. And then the -I times positive I is -I squared. But I'm going to put -1I squared only because when I start substituting my I squareds with -1, it's going to make my math a little bit easier for me. So I'm going to replace my I squared with a -1. All right. And now I'm going to go ahead and say, okay, I'm going to end up with 24 plus 6I minus 20I. A negative times a negative makes that a positive 5 over 16 plus 4I minus 4I. And a -1 times a -1 makes that a positive 1. All right, so now I'm ready to start combining my like terms. So I'm going to combine the 24 and the 5 to give me 29. Then I'm going to combine the 6I and the 20I, or I'm sorry, the 6I and the -20I to get a minus 14I. And then in the denominator, notice that you have a positive 4I and a negative 4I. Well, 4I minus 4I is 0. So we don't necessarily need that. That cancels out. And every single time you do these types of problems, that is going to happen, okay? Remember, the goal here is to get it in proper form, which means you don't have anything imaginary in the denominator. All right, and then we have 16 plus 1, which is 17. All right, so that's a good answer. You could also break that down, and it would be 29 over 17 minus 14 over 17I. All right, now the benefit of doing that, breaking it apart, is because sometimes it will reduce a little bit more. So sometimes part of it will reduce where the other part might not reduce. All right, and that is dividing complex numbers. So now you're going to try the last 3 problems on that page, 9, 10, and 11. All right, and I'm going to show you the answers, not so that you can just copy the answers, but I want you to be able to check your work as you go. So if you're getting these answers, then you can feel more confident that you've done it properly. All right, so those are the answers that you should get.